Okay, number one on the study guide, the ratio of posers to outright frauds was 3 to 7. They totaled 80. So they totaled, they're not telling us how many were posers or frauds, but their total number of all the types of people are 80. How many were posers? So if I put posers to frauds in total as my categories, make a ratio column and an actual number column. We can see the ratio of posers to frauds was 3 to 7. So posers first 3, frauds second 7. And the total, if we add the ratio numbers up, make 10. So again, just maybe make this bar a little thicker and know that we're adding up things on the top to make the bottom. So 3 and 7 are the numbers they give us. They add up to 10. They totaled 80 is giving me the total number, actual number of people. How many were posers is the question, so we're looking for that. I'm going to cross out the fraud row now. That was necessary to get the 10, but at this point we don't need it. That just gets me the fraction 3 over 10 on the left side equals a fraction x over 80 on the right hand side. Then we simply cross multiply. The product of 10 and x should equal the product of 3 and 80. And if 10x equals 240, we divide both sides by 10. And we need x equals 24 posers. Number 2, perimeter of a square is 80 inches. Find the area of the square. So when you're trying to find something involving geometry, find the area of the square, what you have to ask yourself is, what do I need to know? So we're dealing with a square here, and what we know about a square is all the sides are the same measure. So x, 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 x. And we're trying to find the area. An area of a square is simply x times x, which would be x squared. So in order to answer the question they're asking me for, I need to know how big the side is. The information I've given is not what the length of the side is, but we're told what the perimeter is. Looking at this, I know that the perimeter of this square is 4x, but it also equals 80. So if 4x equals 80, we can very clearly see that x would have to equal 20. And once I know x equals 20, the area is simply going to be 20 squared. So area, what they're asking for, is equal to 20 squared, which would be 400. Unit of length in this problem is inches, so we're going to go inches squared. Okay, so on the test, expect to be a square. I'll give you perimeter, ask you for area. Find perimeter first, or use perimeter to find x, and once you know what x is, square it to find the area. Number 3, write 120 as a product of prime factors. All we have to do is find any two numbers that divide into 120 evenly. I'm going to go with 12 times 10. 12 is 2 times 6, and 10 is 2 times 5. 2 is already prime, 6 is composite, so I break that down to 2 times 3. And once I get to all prime numbers, there's the prime factorization. I can go with this answer, which is 2 times 2 times 2 times 3 times 5. I would also be fine with 2 cubed times 3 times 5. All you have to do to verify that you got this problem right, which isn't very hard to do, you guys usually have extra time in class when you're done with the test anyway, so I'd recommend this, is if you just type in your final answer, 2 times 2 times 2 times 3 times 5 equals, it should be the number you started off with. All these numbers should be prime numbers. So if you have all prime numbers and the product is the right number, you have the right answers. That's a self-checking problem. Number 4, g of x equals x parentheses x plus 1. Find g of negative 7. So what they're doing is replacing x with negative 7. So I take this expression and change the x's to negative 7s. So this x becomes negative 7. This x becomes negative 7. Now, you have the option to do distributive product if you wish. My recommendation is to add or subtract inside because we can. Negative 7 plus 1 is negative 6. I subtract it because the signs are different, and it's negative because 7 is bigger than 1. The negative 7 outside hasn't been dealt with yet. At this point, x is being multiplied by this sum. Negative 7 is being multiplied by this sum. Negative 7 is being multiplied by the result of the sum. So these are going to be multiplied together. 2 negatives make a positive. 7 times 6 is 42. Number 5, solve this equation. We have a fraction equation. My recommendation at this point has been to get rid of the fractions. So the least common denominator of the three denominators that I see, 3 and 7 and 21, is 21. Also, I'm going to make note that this x is actually positioned in the numerator. Think of that in the numerator, so 2x instead of 2 7's x. Think of that 2 being multiplied with the x on top. So as far as the least common denominator, 21 would be it. If I do times 21, I can then get rid of the fractions. This is legal because there's an equal sign to the problem. And the multiplication technique that I recommend doing on these, let me just slide this down a little bit so I have some room to draw some arrows. You take 21 times this. Anytime you take a common denominator times a fraction, the bottom number divides that, and then the result multiplies by the top. So 21 divided by 3 is 7. 7 times 1 is 7. 21 divided by 7 is 3. 3 times 2x is 6x. That isn't a fraction, so there's no reduction, it's just multiplication. 21 times 3 is 63. And finally this one here, 21 divided by 21 is 1. 1 times 208 is 208. So the bottom number divides evenly, the result multiplies by the top. You're left with a non-fraction equation, it's easier to solve. If you want to get common denominator, or I should say like terms dealt with, 6x is fine, 7 and 63 makes 70. So 6x plus 70 is equal to 208. Move the 70 to the other side. 208 minus 70 is 138. And then we simply divide both sides by 6. And 138 divided by 6 is 23. If you didn't know that, then again, just calculator, type in 138 divided by 6 equals, it'll tell you what the answer is. If it comes out to a fraction, reduce it to the lowest terms. In this case, it came out to a whole number, so I'd rather have the whole number answer. Number 6, solve. This one has a parentheses issue in it, so we're going to deal with that first. So anytime you're solving equations, getting rid of parentheses should be your number 1 priority. Getting rid of fractions number 2, then combining like terms. All that is simplifying stuff to make the problem easier to deal with. So if I focus just on that, so 3p is going to stay 3p, and equals is going to stay equals, and negative 8p stays negative 8p, negative 13 stays negative 13. All the stuff stays the same. I'm just dealing with the parentheses, or with this distributive property issue. Negative 2 times 5p is negative 10p, and negative 2 times 4 is negative 8. Be very careful that that minus sign is being multiplied. Negative times positive makes a negative. That's a very commonly missed object there. Then the next step, again, if there were fractions, I'd deal with it. There aren't, so I don't have to. The next thing I would deal with would be like terms. These are like terms on the left, and that's it. So if I deal with those like terms, 3p minus 10p is negative 7p. The rest of the problem stays the same. So minus 8 stays minus 8, minus 8p stays minus 8p, minus 13 stays minus 13. You want every equation in algebra to get down to this level. At most, a letter on both sides, a number on both sides. Then it's just a matter of rearranging things. So simplifying, getting rid of parentheses, combining like terms, gets you to the easiest level of the problem. I'm going to move 8p over here. I'm going to move 8 over there. Both objects that moved changed signs, so negative 8 became positive, negative 8p became positive. These are opposite signs, so I subtract. Those are opposite signs, so I subtract. In each case, I put the bigger sign, or bigger number sign on the answer, so 8's bigger, positive, 13's bigger, negative. 1p equals negative 5 is the final answer. 1p and p are the same thing, so you're done. If this was any other number other than 1, though, you'd have to divide by that number in that step. I can't guarantee what's going to happen on the test, but just know that you're going to use a distributive property, and you're going to get to this easiest level, isolate letter, isolate number, and at worst you have to divide by whatever is in front of p at that point. It may not be 1. Number 7, if x plus 5 equals 10, what is the value of 3x plus 7? So if we focus on the question here, what is the value of 3x plus 7? I can't answer that question unless I know the value of x. So this is impossible to do until I know what x equals. So I come over here and take a look at what they gave me. It tells me x plus 5 equals 10. So I'm going to move the 5 over here. That gets me x equals 5. All Alright, that's not the answer to the problem, that's just what x equals. But again, if I move the 5 over, it becomes negative, the signs are different, so I subtract, 10 is bigger, so it's positive, x equals 5. Once I know x equals 5, I'm supposed to evaluate this. X belongs right there because 3 times x plus 7. We substitute the 5 in for x. 3 times 5 is 15, and 15 plus 7 is 22. Follow the order of operations at that point. Multiplication happens first, addition or subtraction happens second. So 22 is the final answer that we're looking for that problem. Number 8, solve for y. Some of you are having struggles with these problems. Let me just focus on the main idea. When you're solving an equation for a specific variable, that means that variable is the key variable. Everything else is not as important as that variable. So if I look at my expression that I'm trying to solve, that's what I'm trying to solve for y, right there. Oops. Drag it down here. So this term has y in it, those terms don't. That yellow term is more important than the other terms. All right? And what we want to do with the more important term is we want to isolate it, get it away from all the other things. So imagine like this is royalty and these guys aren't very important, and this royal guy says, I don't want you near me. So that's what's happening in this problem. So it says solve for y. That's the most important. So it's going to be by itself. Everything that isn't that guy has to move to the other side of the equation. So 10x becomes positive and 6 becomes positive. So you do a separation. So again, if I focus on just this guy, my guy highlighted in yellow, more important than everything else, all by itself equals everything that's not as important as he is. The next step is you don't want anything in front of that number because this y is the king. Okay, 2y is important, but y is more important than 2y. So we're going to divide both sides by 2. This 2 cancels that 2, leaving me with y, which is my most important thing in the world ever, right here. The answer is whatever that is, and again, that's the answer. In this specific case, since everything's even, division by 2 is legal. I might even recommend in this division step, let me just recommend this, so it's a little bit more obvious to see what to do. You have all these terms, each term divides by 2, that's the same as dividing both sides by 2. 10x over 2 is 5x, 6 over 2 is 3. That might be a better way to do it, and get you this nice simple answer the best, easiest way possible. But again, that's all the steps necessary. Get what you're trying to solve for, that term by itself, divide by whatever's in front of that term, divide every term by it, and then simplify if possible, and that's it. Notice I didn't divide by y, just divided by 2. Y is left on the left, only things that aren't y on the right. Keep those separated. Again, some of you are dividing by 2y here. Just divide by 2. We're trying to keep y by itself. So y just kind of comes along for the ride. The number disappears in that step. Number 9, find the least common multiple of 3, 18, and 12. So 3, 18, and 12. Okay, first thing I'm looking for is prime power factorizations of each of these things. So 3 is prime, can't do anything to it. 18 is 2 times 9, and 2 is prime, 9 is 3 times 3. So 18 is 2 times 3 squared. And again, 3 was just 3 to the first. Then we have 12. If I do a prime factorization of 12, 12 is 2 times 6, 2 is prime, 6 is 2 times 3. I can see that's 2 squared times 3. So that's job 1, is to get the prime power factorization of each object. So 3 is 3 to the first, it's prime, can't do anything to it. 18 breaks down to 2 times 3 times 3, which is 2 times 3 squared. 12 breaks down to 2 times 2 times 3, which is 2 squared times 3. That's priority 1 and least common multiple problem. Priority 2. Looking inside this blue box, every single prime number that occurs matters. So I'm going to write LCM equals, and then I look and see what's in there. There's 2's and 3's, and that's it. So 2 matters and 3 matters. It doesn't matter that there's 2 2's and 3 3's. It doesn't matter there's a 3 in every one. There's just 2 in these 2 and not that one. If there's a 2 and there's a 3, they all matter. And then I'm going to take the highest power of each thing. So this 2 is to the first. This 2 is to the second. 2 is bigger. First, second. First, second, that's the biggest. So 2's biggest is 2, 3's biggest is 2. And then what it's left to do is to multiply it back together. 2 squared is 4, 3 squared is 9, 4 times 9 is 36. That's how you find least common multiple. That's the technique I would use. It's the most efficient way to do it every single time. Number 10, factor the greatest common factor of. Okay, first off, when we look at an expression, this is term 1, and this is term 2, and they're separated by a minus sign. Terms are separated by pluses and minuses and equals. So when we're considering what's a term, that's how we decide. So things that are being multiplied together, then once you add or subtract, you're creating a new term, then things are being multiplied together. So this has 2 terms. We're trying to find the greatest common factor of these guys. Now, for greatest common factor's sake, if we focus on the factored form of just the numbers. Okay, so we have 3 to the first is the factored form of 3, and 3 to the first times 5 to the first is the factored form of 15. We can worry about the letters in a minute. For common factors, this says common. To be common factors, they have to have things in common. So looking at these 2 things, they have 3 in common. They don't have 5 in common. And we're allowed to take the lowest power in this situation. So going back here, least common multiple, I'm taking the highest power. For greatest common factor, we're taking the lowest power. It's weird, backwards, but they're both backwards the same way, so that's how you do it though. So 3 to the first is common to the numbers. And then looking at x is common, and x to the first is what we can take out. Again, the smallest power. And then y is common, and our choices are 1 and 2. Y to the first is what's common. Okay? And if you want to see why the commonality thing is the lowest power, this is an easy way to figure it out. If I were to write these in expanded form, there's 3x squared y, there's 15xy squared. And looking for common, 3 is the same as 3, x is the same as x, y is the same as y. There's an extra x here, but x is no longer common because we've already used that one up. So the smallest power is what's common, the extra power isn't common anymore. Y is the smallest power, this extra y isn't common anymore. So that's why the lowest power is what's being pulled out for greatest common factor. Then, the other step of greatest common factor is we write a leftover. There's 2 terms, and we want to put inside here what's left over. This minus sign is going to separate the 2 terms. And I got term 1 and term 2, and that's whatever's left over. If I take 3xy out of each term. Well, if I take 3xy out, what's left is x. If I take 3xy out, what's left is 5y. You can do it this way, but it's also by division. 3 divided by 3 is 1, understood 1. X squared divided by x is x, y divided by y cancels. Negative 15 divided by 3 is negative 5, x divided by x cancels, y squared divided by y is y. Ideally, you get from here, division, to get to there, but this is a little thing you can do right now until you get to the point where you're always getting these right. That technique works every time also, and it's a little bit more noticeable. That's left over as far as getting whatever's left over when you extract that common factor. Number 11, simplify. Once again, if we identify terms, terms are separated by pluses and minuses and equals, and also I'm going to add to that fraction bars. So what I have highlighted in yellow are 3 separate terms, and what I'm looking for is what I can divide out of each of those terms evenly without breaking any rules. So looking at, again, I'm basically finding the greatest common factor here. So looking at those 3 numbers, 4 and 32 and 4, 4 is 2 squared, 32 is 2 times 2 is 4, 8, 16, 32, so 2 to the 5th, and then 4 is 2 squared. So the greatest common factor of the numbers is 2 to the 2nd power. Looking at the x's, x squared, x squared, x squared, obviously it's x squared. Looking at the y's, y squared, y, we got y to the 1st. So 4x squared y is what I can take out of each of these guys. So, this is again a division. Alright, if I do 4x squared y divided by 4x squared y, I get 1, and it's a necessary 1, because that's a term I need to make a term. So 1 minus 32 divided by 4 is 8. X squared divided by x squared cancels. Y squared divided by y is y to the first. 4 divided by 4 is 1. X squared divided by x squared, y divided by y both cancel. So 1 minus 8y over 1, which is the same as 1 minus 8y. This one's important because it's 1 minus. This one's not important because it's divided by 1. Divided by 1 doesn't do anything. So 1 plus or minus something matters. Divided by 1 doesn't matter. So we can throw that one out. This one has to stick around. Number 12, simplify. First thing I would do with that is put the negative powers where they belong. So this is on the bottom negative, this is on the top negative, everything else is a positive power. So I would rewrite this, p to the 6th, z to the 3rd, over z squared, p to the 4th. All four of those objects didn't move. P to the 6th stayed where it was, z cubed stayed where it was, z squared stayed, p4 stayed. The two terms I have circled in blue, z to the negative 4th belongs on top. Once I move it where it belongs, it becomes positive 4. P to the negative 2nd on top belongs to the bottom. Once I move where it belongs, it becomes positive 2nd. So that's the first thing I would do. Fix my negative powers. The second thing I do, I look at the top and bottom separately. So the top and the bottom. And looking at top, I'm asking myself a simple question. Is there more than one of any letter? If there is, I got to fix it. So on top, there's one P, there's too many Z's. On the bottom, there's one Z, there's too many P's. Okay, so what I have circled there, I'm going to use the rule that says if I multiply letters, I add powers. So at this point, P to the 6th on top is not being affected, Z squared on the bottom not being affected because they're not circled. On top, there's too many Z's, I'm going to get one Z, 3 plus 4 is 7. On the bottom, there's too many P's, I write 1 P, 4 plus 2 is 6. Okay, so that's the second thing I would do. The final thing I'm going to do is now I'm going to look at this as a fraction, and I don't want to have more than one letter in the problem. So there's too many P's, and there's too many Z's. If you go alphabetical order, you don't have to deal with this crossing of things, but in the magenta circle, the P's, in the black circle, the Z's. And in the magenta circle, if they're exactly the same on top and bottom, they cancel. If everything cancels, the answer is 1. All right? In this case, only the P's cancel completely. As far as the black circle is concerned, Z on top, Z on bottom, we've got to decide where it belongs. So here's a fraction bar. Z is bigger on top, that's where it belongs, and we subtract 7 minus 2 is 5. It goes over 1, which again, I would probably just write it Z to the 5th. I'm not going to count that wrong. If you want to put the over 1 right now, that's fine. Hopefully you get to a point where you're more comfortable just getting the answer like that. So Z to the 5th power. Whether it comes out to just a letter to a power on the test, it'll at most be P to a power, Z to a power, but maybe something cancels out, I don't know. But again, fix the negative powers, fix the too many of a letter on top and bottom by addition of powers, fix too many letters on top and bottom by subtraction of powers, put in the answer where the bigger power belongs. And again, if you happen to get an exact same one, just cross them off, they cancel. Number 13, expand using the distributive property. Priority 1 here. Notice we have a term plus a second term times a third term. So I guess parentheses also separate terms. So this guy outside is multiplying equally times both terms inside. And what I'm noticing about everything is everything has negative powers. Negative third power, both negative third powers. This is in the bottom, belongs on top. Both of these are top objects. There's no fraction, so it's understood top. So both of these things are going to move to the bottom. So first thing I'm going to do is rewrite the problem in a better form. So m cubed is fine on top. Y cubed belongs on top with it. I'm going to put it over 1 to make it a fraction. Plus 7m cubed are all fine. They're behaving themselves, staying on top. Y cubed belongs on the bottom. And then both of these are needed to move, so m cubed moves down, y cubed moves down, and to make it a fraction, we're going to put a 1 on top. That's priority 1. Make everything into a nice non-negative power structure. Step 2, we're going to multiply. Some of you, and it doesn't matter on this problem because it's plus, but sometimes it's minus and it does matter. Some of you are doing this. You're going to this one first. When you multiply with the distributive property, always go to the leftmost term first. Always go there first. So first go there to get a product. So I'm multiplying top times top and bottom times bottom. I can clearly see that things cancel. I don't care. Okay, don't care about canceling right now. Just get an answer. 1 times m cubed y cubed makes m cubed y cubed. M cubed y cubed times 1 makes m cubed y cubed. Top answer, bottom answer. Then I'm going to multiply this times this. When I multiply these, I have to worry about sign. 1 times 7, both positive, makes a positive. M cubed on top. So 7m cubed times 1 on bottom. M cubed y cubed times y cubed makes m cubed y to the 6th. Since we have the same letter, go ahead and add the powers. All right? Don't cancel anything in that step, but just get answers and then worry about canceling if possible. And it's just the same as the last problem was. I have too many m's, they're being divided. I have too many y's, they're being divided. I have too many m's, they're being divided. 1, 7, 1 y, everything's fine with that. So, looking at this first term, m cubed over m cubed exactly the same, they cancel. Y cubed over y cubed exactly the same, they cancel. Everything cancels from this term, but notice there's 2 terms. We have to have 2 terms. Everything cancels, the answer is 1. If you leave that 1 off, you will be wrong. Something plus requires an object to be there. You cannot just leave it blank. So everything cancels out. There's officially still a 1 being multiplied by all that stuff. That 1 has to be included in the answer. Here the m cubed over m cubed cancels also. That gives me 7 over y to the 6th. This term's a fraction. This term isn't a fraction. Make sure that fraction bar doesn't extend beyond the plus sign when you write your final answer. That's the best I can do with that one. Simple term, addition. Again, if there's a minus sign here, that'll be a minus sign there. When you multiply, worry about signs when you multiply. And again, do this one first, this one second, get in that habit. It doesn't matter which side this is on. Always go to the leftmost in the parentheses, then go that direction. Number 14, evaluate m minus 3m to the negative second if m equals 7. Let's not worry about m right now. Let's worry about this expression. So whenever I do a problem like this on a test, and the study guide has this problem, this expression to evaluate, that's what's going to be on the test. So that's the expression that's going to be on the test, so let's focus on that first. Again, I, at this point, don't care what m equals. Looking at this expression, m minus 3m to the negative second, anytime you deal with a power, you have to ask yourself what's being raised to the power, and there's no parentheses, so only m is being raised to the negative second power, the 3 is not. And this minus sign separates terms. So that term right there has a negative power in it, this term doesn't. So this first m just stays m, the minus stays minus, the 3 stays on top, the m squared moves to the bottom. So rewrite the problem into a structure that's easier to evaluate. So that's an easier to evaluate structure. Step 2. Look at what you have in your structure. I have m, no big deal, and I have m squared. Okay, all I know is what m equals. So they told me m equals 7. That's helpful. I can figure out that m squared, therefore, is equal to 49, because if I square m, I square 7. So 7 squared is 49. So I know also this fact. Okay, for me personally, I like to figure out what all the pieces look like before I start substituting stuff in, because then it's easier to substitute. So, if I start substituting stuff in, m is 7, so put 7 there, minus is minus, 3 is 3, over, m squared is 49. And just like that, I've created myself a nice little structure here that gives me a nice, easy to deal with subtraction problem. Now, this is subtraction of fractions. I expect you to do it. You have 2 choices. Choice 1 is subtract 7 as a whole number minus 3/49 as a fraction. I can't subtract 3/49 from nothing, so I have to make this 6, and this is 49/49. 6 plus 1 makes 7. That's equal to 1. 49/49 minus 3/49 is 46/49. That's exactly right. That's a fine way of doing it. If you want to do it that way, more power to you. Okay? Again, it requires borrowing from the whole number to create a fraction that can be subtracted in order to create a new fraction answer with the correct whole number. If you're not as confident with your borrowing skills, the other option is this. 7 currently is over 1. That's being subtracted by 3/49. I want this to be something over 49, so I multiply top and bottom by 49. 7 times 49 on top is 343. And once I get them both with the denominator 49, 343 minus 3 is 340. Okay, both these answers are correct. I'll take either one. I personally do it the blue way down here. If you want to do it that way, though, you're welcome to do it. I'll figure out what the mixed number version is when I do my test. Number 15, find the area of the shaded portion of the parallelogram. Dimensions are in feet. And the area formula for a parallelogram is the base times the height, which is on the formula sheet. I got a formula sheet here. I'll bring it close. It's right on the top line under the heading of parallelogram. All right. If you look at that sheet, rewind if you have to, the base is 12, the height is 9. Okay, when it says base and height, it's looking for a base and a perpendicular height. So the area of the parallelogram here is simply going to be 12 times 9, which equals 108 and feet squared. Okay, the circle's being cut out of the parallelogram, so we're going to subtract the area of the circle. Area formula for a circle, also on the sheet, is pi r squared. And if you look, here's the sheet again, and right in this corner over here is the circle stuff. You got the area formula for a circle. Okay, the radius is 3. So the area of the circle is just going to be pi times 3 squared. We can do that in our head. And if we use 3.14 to approximate pi, we get 28.26. If you want to use the pi button, it'd be a little bit larger, but I'm fine with 3.14 for approximating in Algebra 1. So the parallelogram is everything. So if I look at the parallelogram, this is the parallelogram right here. That's 108. And then the circle's being extracted, cut out. So imagine you get a pair of scissors and cut this area out. That's this. So we're subtracting the circle from the parallelogram. So 108 minus 28.26. In order to subtract decimals, I got to line up decimal places. So decimal points. So 108 officially has a decimal here. I'm going to put zeros in order to do subtraction. That becomes 7. This becomes 10, which drops to 9. So make this 10. 10 minus 6 is 4, 9 minus 2 is 7. Bring the decimal down. 7 minus 8 can't do it. This becomes 0, this becomes 10, drop down to 9 to make this into a 17. 17 minus 8 is 9, and 9 minus 2 is 7. So 79.74 feet squared is the area of the shaded portion of the figure.